Hello class, let's take a look at example 2. So take a second and read it. And here's the main idea. So we know that they're talking about IQ scores, and IQ scores, we're told that they're bell-shaped. And not only that they're bell-shaped, but the mean and the standard deviation happens to be technically 100 for the standard deviation. Sorry, 100 for the mean and 15 for the standard deviation. Now, here's the main idea. They want us to evaluate the probability that if one subject is randomly selected, what's the probability that they have an IQ score of at least 133? So in this case, because they're talking about a single subject, we're back to section 7.1, 7.2. Now, remember that you have to declare the variable. So in this case, you're going to have to say, let X be a subject that has a specific IQ score. Then we're looking for a actual value that the IQ score happens to be greater than 133. Now, for this particular one, we can just run the normal CDF, and let me give you the code. So we're going to be actually running the normal CDF. So in the code, you're just going to do second distribution, activate the normal CDF. Now, this particular one says greater than or equal to 133. So your lower bound, it's going to be 133. Your upper bound, it's going to be a very large value, enough zeros, as long as it doesn't actually freeze for the calculator. Then don't forget the mean of 100. And then the last portion of it would be the standard deviation. There's no adjustment on the values of 15 because technically the actual C-score happens to be for a single individual. So you're still talking about one selection. Please run it and see if we're actually matching. This is what I'm getting on this particular one. So this particular one, it's giving me a final answer of 0.039 for the probability of a single subject having at least 133 of an IQ score. Let me give you the code. And see if you guys are matching with that one. Now, the second question for this problem, they're basically just adding one new factor. This is the idea of 9 individuals. So we're still going to be evaluating the probability that X is 133, but because you have 9 subjects now, you're going to be evaluating the following formula. So in this case, we're going to use the sample, well actually the population, but for a sample C-score, so you're going to be dividing by the square root of n. So in essence, we're working on the same problem as A, except that we need to do a minor adjustment. Now, the adjustment here on the shortcut, it's done by using the following trick. So I'm just going to be activating the previous command, and I'm just going to divide the standard deviation by the square root of technically n, in this case the square root of 9, which is going to give you the values of 3. So what I'm doing on the calculator in this portion here, it's actually the portion that is here. So I have sigma divided by the square root of n, and that gets adjusted in this actual portion. So we're just adjusting it here. So please run the code, see if you're actually matching. And in this case, well, I'm rounding to 3 decimal places, but the probability ends up being really small. It's 2.06, technically 7 times 10 to the, whoops, this is supposed to be negative 11, which actually represents a value very close to 0. Here's the code for this one. Since the only adjustment that we're doing is that we're dividing the standard deviation by the square root of n. Okay, take a look and see if you guys are actually matching